where you couldn't just see it. But you guys are so talented and gifted, I'm encouraging you to, speed is part of the, what? Yeah, I'm fine with it, as long as you get it right. Okay. Okay, so let's keep going here. In parentheses, 49.05 minus 34.5 divided by 37. It's 0.39324 meters per second squared. I'm going to store that in my variable a for acceleration. Now, how do we find the tension? Do we substitutulate? Yeah, we're going to substitute in, I'm going to substitute in for this guy here. Okay, so T minus 34.5 and counting equals 32 times 0.39324, right? I'm actually using the variable a in my calculator, so that times 32 plus 34.5. And I get that the tension equals 47.08. Are we done? No, we're not done. Your math teacher would be like, they wouldn't get a pain, they would just sort of get like a random itching like on their elbow or something like that, right? If you, what should we do? We're good. We should check our answers. We should plug it in to this one and see if we get the same thing, right? So 49.05, right, minus t equals 5 times 0.39324, right? So 5 times alpha a, okay, minus 49.05. Yeah, I get the same thing. I get t is equal to 47.0837, et cetera, newtons. So the world is all good. I don't think there's anything else we could do. So schwer ist es nicht, yeah? We didn't learn this sentence, did we? No. Okay, repeat after me. Das Telefon klingt. Das Telefon klingt. That's not too hard. So telephone, right? We just say telephone. As far as I can tell, it's like almost exactly the same way the English speakers say it. Klingt means rings, or actually literally means sounds. It's the word that means sounds. So in German you could say, das klingt Französisch. That sounds French. Das klingt Deutsch. That sounds like German. Das klingt, it sounds like something, right? Okay, that's kind of cool. Does French work that way too? Can you say sonne, can you use sonne the same way? I don't even know. I'll ask Brianna. She's as close as we have to a native speaker, right? For French. Do you speak French? Sonne, can you use sonne as in like sounds like?
Wait, what was the word for French in German?
Französisch. Französisch. And in French, the word for German is Allemagne. Isn't that great? Whoa, look at us go. Look how fast you're learning. Okay, here's the one for you, and you have just the right amount of time to solve this. This is a problem that is so famous that it's called Atwood's machine. So apparently it was designed by like Atwood, and the machine does like nothing at all. Actually, this is the basic idea for an elevator, is that whenever an elevator moves up or down, there's actually a counterweight on elevators, most elevators, not our elevator, but on elevators that run on cables. There's actually something called a counterweight that has as much weight as the elevator shelf, the shell itself, right? And then when people get in, all it has to do is lift the people. It doesn't have to lift the elevator and the people, right? That's kind of crazy. In the theater, they've got these things that they raise and they lower, and they have counterweights on those things that are equal to the mass of those things. So really all you have to do is overcome the friction. You don't have to hoist a giant heavy curtain up and down. Thank God. Because a curtain probably on the theater weighs 300 or 400 pounds at least, I would think. Probably each side weighs 300 or 400 pounds. It's crazy. And then the final thing, in the theater there's actually a fire shield, a fireproof thing that can come down. Fire curtain, so that if there ever is a fire backstage and all that material starts catching on fire, all the wood sets and everything, they can like cut it off. And presumably the actors are like sacrificed. They're like, ah, right? They try to get like under the fire curtain before it falls. Or they can go out the back door. Yeah, there's plenty of exits.
But that's not as amazing.
Okay, so what I want you to do, boys and girls, step one for this, I want you guys to calculate, do step one, calculate and label all the forces and decide which way the acceleration is and make that way positive. Okay, do that right now. And then you can have a brain vacation. So don't you have to calculate the weight? Yeah, there you go. We know this guy is 49.05. When you've calculated the weights, when you've labeled the direction of the forces, and when you've labeled all the forces, look up at the whiteboard. Don't look at it before then, though. That's cheating. Sure, I'm going to do it the way I showed you, but yeah, there's simpler ways. Yeah, you can just go this minus this over 8. That's always the answer. There you go, yeah. Do we have this? So, and then I've decided that the 5 is going to accelerate down somewhat surprisingly and the 3 up, right? You're probably surprised by that, right? By the way, if you guess wrong, if it's not obvious, like if this guy's resting on an inclined plane or something like that and you don't know whether it necessarily accelerates up or down, if you ever guess wrong, you'll get a negative answer for A and then you'll go, oh, whoops, right? Okay, but I'm sure I'm right on this one. So go ahead and set up your equations. I'll set up mine, you set up yours. And then once, of course, you have the equations, go ahead and solve them. I just picked up the remote to my camera and tried to do calculations on it. It's very bad for that sort of thing. Let me stop the video.
It would be creepy if it actually worked.
All right. Oh my God. It's the acceleration ends up being 2.5. Did you guys get that? Yeah. Yeah.